Okay, let's go back to my previous video. I did make a mistake. Right here on this particular problem, number 32, when I added a positive 4 and a negative 2, 4 minus 2 should have been plus. So this should have been a plus. Please forgive me for my mistakes. And also on number 34, this particular problem right here, this is correct according to my work. Or I'm going to say correct based upon my problem, but I read the problem wrong. The writing was so extremely small, I messed up on one of the exponents. So forgive me on that. But I'm going to go on. I don't re-record videos, and I told you I made a mistake, so I'm correcting that as we go along. Let's look at number 38. This is a factoring problem. We have 6a squared minus 7a minus 5. This is tremendously important and also something that was greatly missed. So here's what I do. I multiply the first term times the last term. That's going to be a negative 30. That goes in the front of what I call my T-chart. Then I take the middle term, including the sign, which is a negative 7. That goes on the right-hand side of my T-chart. I'm looking for two things that will multiply together to give me a negative 30, and those exact same terms have to add, to give me a negative 7. So let's see, that's going to be a negative 10 times a positive 3 and a negative 10 plus a positive 3. So these are what you call your factors, okay? Now, here's what I do. I take the lead term, but not the exponent, just the 6a, because that was the lead term. I put it at the front of two parentheses. So 6a goes at the front there, 6a goes at the front there. I take my factors that I found and I put them at the back. Negative 10 goes here, positive 3 goes there. And then I reduce. Now, it just so happens that both of these can be reduced. When you reduce, that number vanishes. It goes away. So let's see. This is divisible by 2. This is also divisible by 2. So my answer here is going to be 3a subtract 5. This is divisible by 3. This is also divisible by 3. So my answer will be 2a plus 1. If you were to FOIL this out, you would get the term that you started with. So this should FOIL and give you that term right there. Factoring is extremely important. Okay, last one from this particular section is number 39. This is what I have affectionately termed the breakup story, and rarely ever does anybody miss this, but occasionally you do have somebody that gets confused. This is going to break up to 2a and 2a. This is going to break up to 3b squared and 3b squared. Remember, these people are having their differences. Differences means they're not getting along, things are not going well. Subtract is another word for difference. This is called difference of perfect squares. And if they're having their differences, they need to break up. Well, when they break up, a 2a has to be at the front because that's what started the problem, 2a, 2a. And then you're going to have a 3b squared at the back, 3b squared at the back. And one parentheses goes to remember the happy times, and the other parentheses goes to remember the sad. And again, that's called the difference of perfect squares. I refer to it as the break-up story. It only works when you have two people, and they must be having differences. It has to be a subtract, okay? It doesn't work for anything else. Moving right along to the last section, which is section 1.4. This is where we started talking about imaginary numbers. Okay, here we go. Number 42 is negative square root of negative 8x. I've got to make sure that my recording is still functioning properly, and for some reason it's wanting to wig out. All right, the first thing we need to do is hop out this negative. So this negative needs to hop out, and that will be a negative. Then we have an I, and then we have the square root of 8x. So you have to take out the negative first, just like you do in anything else. This is going to be broken down to the square root of 4 times the square root of 2. We know that the square root of 4 is 2. So on this negative I, we're also going to have a 2 because the square root of 4 is 2. So that goes away. And stuck in the radical, we're going to have that remaining 2 and that x. Number 43, this is a great problem. I cubed square root of negative 9. Okay, I'm going to hop out that I first. I already had 3 i's out, so now I'm going to have 4 i's outside of the radical and just a plain square root of 9. If you remember your terms, I1, and then you put a negative on those, this is the same as I to the first power. This is the same as I to the second. This is the same as I to the third. And this is the same as I to the fourth. So since I to the fourth is equal to 1, I can simplify this 1. The square root of 9 is 3. And so my final answer is just a plain 3. Number 44, we're asked to combine like terms. We have 7 minus 2i plus 9i minus 5. You can add your i's. Negative 2i plus 9i is going to be a positive 7i. And then you can add those constants. 7 minus 5 is 2. So it's going to be 2 plus 7i. Number 45, we are asked to FOIL 3 minus I and then 6i squared minus 4. Let me show you a shortcut here. You can FOIL it out, but this is a really cute problem because they have a really neat shortcut. Remember I told you up here that I squared is equal to negative 1? So anytime you have an I squared, you can just scratch it out and put a negative on that number. Now let me say, if it was a negative, you scratch it out and put a positive. If it was a positive, you scratch it out and put a negative. So here's my next step. I have 3 minus I, can't really do anything there, and then this is just going to be negative 6 minus 4. And that made my problem a whole lot easier. I'm not even going to have to FOIL here because a negative 6 and a negative 4 is a negative 10. So I just need to distribute kind of backwards like this. Negative 10 needs to be distributed. And so my answer will be negative 30 plus 10i. Now you could get this same answer if you FOIL. You can FOIL the original problem, but what I just did with that little shortcut is a lot quicker. Remember, an I squared is always equal to a negative 1. Okay, number 46. This one is going to take a lot of time. And for some reason, my video keeps wigging out on me. All right, we have 3 plus 4i on top. We have 3 minus 4i on the bottom. This is a binomial, and we're going to have to rationalize that denominator by multiplying the top and the bottom by the conjugate. The conjugate is the exact same term, so we need a 3 and a 3. We need a 4i and a 4i. But you have to change the sign in the middle. Now, we're trying to rationalize the denominator, not the numerator. So you need to get rid of that subtract 4i, and your conjugate would be plus 4i. This is called the conjugate. That is super important. Now, you're going to have to flat out FOIL this top. 3 times 3 is 9. 3 times 4i is 12i. 3 times 4i is another 12i. And a 4i and a 4i is a 16i squared. For the denominator, these are conjugates. So you only have to do the first and the last because these are conjugates. So 3 times 3 is 9 minus 16i squared. Now we're going to use our trick. If you see an I squared, scratch it out and change the sign on the number. So this is going to become a subtract 16. And scratch this one out. This will become a plus 16. See that? That's a shortcut. So now I have 9 minus 16, which is negative 7. 12i plus 12i is 24i. And then in the denominator, 9 plus 16 is 25. If I could reduce those three, if the negative 7, the 24, and the 25 had some type of common term, you would reduce it, but they can't be. Let's see how my time is looking because you can only record. Okay, it's 9 minutes. Let's keep going. Number 47, I really want to finish these up. We've got the square root of negative 3 times the square root of negative 16. Hop out an I here. Hop out an I here. I've got I radical 3 times I radical 16, We know I times I is I squared. I know I can't take the square root of 3, so that's going to stay the square root of 3. The square root of 16 is 4, just a regular 4. I know that I squared is equal to -1. I can't do anything with the square root of 3. I have my 4, and when you multiply all those together, I get -4 radical 3. Now, another way you could have done that is you could have gone back here and scratched out that I squared, and knowing that that's going to change it to a negative. That's where that -1 came from. Number 48. 8 minus the square root of -2 quantity squared. The very first thing you need to do is hop out an I. So I'm going to hop out an I, and then I'm going to write that twice. So it's going to be 8 minus I radical 2 twice. I'm going to FOIL that really quick. That's going to be 64 minus 8I radical 2 minus another 8I radical 2, and then a negative times a negative is a positive I squared. Radical 2 times radical 2 is radical 4. We're going to do some simplifying here. These middle terms can be combined right here. A negative 8I radical 2 and a negative 8I radical 2 is a negative 16I, but still a radical 2. I know anytime I see an I squared, I can scratch it out and change what was an addition to a subtraction, and the square root of 4 is 2. So I can put those last two together. 64 minus 2 is 62 minus 16I radical 2. That would be the answer for that particular problem. And let's check our time. Let's try the last one. Number 49. It's going to be the... Well, nah, it's not that bad. All right, number 49 is 2I square root of -27 over the square root of -16. Hop out an I, hop out an I. So on the top, I'll have 2I squared, and then square root of 27. And in the denominator, I'm just going to go ahead and take the square root of 16, which is 4, and then I also comes out. Now watch this. This is another shortcut. I can simplify this, 2I squared divided by 4I. I can reduce that. 2 over 4 is going to reduce to 1/2. And if you have an I squared on the top and 1I on the bottom, that's just going to leave you with 1I on the top. And that is helpful because I won't have to rationalize my denominator now. Okay, all I have to do is simplify the square root of 27. That's going to break down to the square root of 9 times the square root of 3. We know that the square root of 9 is 3, so we're going to have 3I radical 3 on the top and 2 on the denominator. Okay, that's it for those review problems. I hope that's been helpful. And so practice it on your own and then come back and watch my video and see what you can do.